The notes for Unit 6, Lesson 5 will cover the combined gas law. So this is the fourth gas law that we will learn and practice this unit. We have Boyle's law, Charles' law, Guy-Lussac's law, and then the fourth one is the combined gas law. So after the notes for today, you will be able to calculate unknown variables when using the combined gas law. So make sure you have your notes packet and make sure you have a calculator. So as you can imagine, the combined gas law combines all three of those previous gas laws into one. So with the combined gas law, now you have pressure, volume, and temperature that are all changing. So the equation that we use is P1 times V1 over T1 is equal to P2 times V2 over T2. And then just like before, all temperature values must be in Kelvin. So if you look at the equation for the combined gas law, you can actually use this for all the three previous laws, because if you're reading a problem and it only mentions pressure and volume, but it doesn't say anything about temperature, you just leave out temperature, and there's Boyle's law. If you're reading through the problem and the problem only mentions pressure and temperature, so it doesn't say anything about volume, so if you get rid of volume, there's Guy-Lussac's law. And if the problem doesn't mention anything about pressure or pressure stays constant, you get rid of pressure, and here is Charles' law. V1 over T1 is equal to V2 over T2. So that's how they got the equation for the combined gas law. All right, here's a sample problem from your notes. So we're going to use the same process as before. We're going to write down all the information that's given and then plug in our numbers and solve. So we have a gas at 155 kPa. So kPa is pressure. And 25 degrees Celsius. So temperature is 25 degrees Celsius. And an initial volume of 1 liter. The pressure of the gas increases to 605 kPa. So that would be our second pressure reading, as the temperature is raised to 125 degrees Celsius, so that's our second temperature reading. And we want to know what is the new volume. So our second volume is our unknown variable. Before we plug in any numbers, we know temperature has to be in Kelvin. So if we add 273, we'd end up with an initial temperature of 298 Kelvin. And a final temperature of 398 Kelvin. So you can do that right away if you want to, so you don't forget. And then our equation is P1 times V1 over T1 is equal to P2 times V2 over T2. So then we're just going to plug in our numbers and solve. So P1 is 155 kPa. Times V1, which is 1 liter, over T1, which is 298 Kelvin. And that's equal to our second pressure, which is 605 kPa, times our second volume, which we don't know, over our second temperature, which is 398 Kelvin. So here's all of our variables. So you can, again, solve whichever way makes more sense to you. You can solve for the left side of the equation and then move over to the right to solve for V2, or you can cross multiply. So if you cross multiply, you would multiply everything across the top. So you would take 155 times 1 times 398 is equal to 298 times 605 times V2. So if we cross multiply, I get my calculator up here, we have 155 times 1 times 398, which would give us 61,690. And the units don't cancel out yet. So we still have kPa, we still have liters, we still have Kelvin. So I'm going to include all of those units. And then we're going to now multiply in the other direction. So 298 times 605, which is 180,200 290, again, the units do not cancel out, whoops. So we have Kelvin times kPa, and then times V2, which we don't know. So to get V2 by itself, if you want to add the parentheses to these, to get V2 by itself, you would divide each side by 180,290 Kelvin times kPa. So that cancels out 290, whoops, Kelvin times kPa. So Kelvin cancels out, kPa cancels out, and we're left with liters, which is where we get our volume value. So 61,690 divided by 180,290, and we get a volume of 0.3421795. And of course, we have to round to significant figures. So if we look at the numbers in the problem, 155 has 3 sig figs, 298 has 3, 1.00 has 3, 605 has 3, 398 has 3, so we're going to keep 3 sig figs. The 1 is not going to cause the 2 to round up, so we would cut all of these numbers off and end up with 342, and then remember the only unit that didn't cancel out was liters, so we're going to end up with 0.342 liters. That would be our second volume based on this scenario. So again, process is the same. You plug in the numbers, and then like I said, you can cross multiply, or you can solve for one side and set it equal to another, whichever way makes more sense to you.